So here's a first order, it's actually first order linear differential equation. Y prime, it can be made into the y prime plus py equals q format, and we can solve it with an integrating factor. We're not going to do that. We're going to do Laplace transforms. So right down here, I've got the transforms of each of the pieces. So this is from the chart. These are things we would have already proved. The Laplace transform of y prime is sf minus y naught. Y naught is that initial condition, so y naught is 4. The transform of y is just f. The transform, so that's what I mean by this. This f is also the transform of that unknown function. The unknown function is the answer to this differential equation. The transform of sine 2t, the transform of e to the 7t. So each one of these pieces are the transform of a piece of this equation. So let's take this equation and take the Laplace transform of the entire equation. So the transform of y prime is going to be that sf minus y naught. The transform of y is f, then plus 4 times the transform of the trig function. And I guess it's 4 times this. Let's put the 4 times the 2. We'll make that an 8. We'll clean that up. Then the transform of e to the 7 times 10, that's going to throw a 10 on top of that. So plus, so I've taken the transform's a linear operation, so the transform of this sum is the sum of the transforms, and y naught, that's the number, that's 4. So now this is the transform of the entire differential equation. Now all I want to do for here then is solve for f. So I'm going to have the machine do a lot of the steps for me for laziness, but also for brevity. So I'm going to just ask it to solve. So you would just mechanically solve for that. And let's clean this up. Well, yeah. So this is not how you would get the answer. When you're doing it by hand, and you should probably pause the video and check this out by hand. But when you do it by hand, you'll probably get this. The s minus 7, that corresponds to that e to the 7t. This s minus 2, that's the, where does that come from? Well, that's this 2 here. That would be the homogeneous solution if I was solving this the chapter 4 way. And this s squared plus 4, that's the trig, that's the sign. So see what we did. We took the Laplace of the entire differential equation using our chart, incorporated the initial condition, then solved for f, and now again I'm going to use the machine to do this quickly, but you would ask this, you would do partial fractions on it. There's the partial fractions. Now let's clean this up a little bit. We want to unLaplace this, inverse Laplace this, so we want each piece to look like something from the chart. So here I've got this minus with this s plus. I'm going to split that over that plus sign. So I'm going to end up rewriting this piece. That's me distributing this minus that piece across that plus sign. Now we're set. Each one of these pieces, I can take the inverse Laplace of. So let's do that. The inverse Laplace of f is y. This one's going to be 3 e to the 2t plus 2 e to the 7t minus, okay, this one with the s up top, that's going to be a cosine. So cosine 2t and minus sine 2t, taking the inverse Laplace of them. And I guess I'm done. The only thing now to do is maybe check and make sure if I make t equal to 0, do I get 4 out? When t is equal to 0, that's 3 plus 2, e to the 0 is 1. So 3 plus 2, that's 5, minus 1 plus 0, yeah, it works. and I have all the pieces that I think I should have, right? If I was going to do this first order linear, y prime plus py equals q, this would be my, with the 2t would be my homogeneous solution, and then I would need a particular solution that would have to have an e to the 7t, got it, and with the sine 2t there would be a cos 2t and a sine 2t piece. But anyway, solved.